Welcome to this special climate outtake of Burning Earth Radio. This is your host, Gerard Spring, coming to you from the subarctic. So what you're looking at here, folks, is a program called Earth Null School. And Earth Null School is a really cool climate analysis program that you can use to look at various wind patterns, temperature patterns, and it allows you to get an overall sense and feeling for what's going on with the climate system visually. So I highly recommend it. I'll post a link to Earth Null School in the comment section below so you can take a look at it if you're interested. I highly recommend taking a look at Earth Null School, maybe once a week or even once a month to just get a sense of the overall changes and what's happening with the climate system overall. So without further ado, I'd like to take a look at the Jetstream. So this is the Jetstream, folks, and what the Jetstream is it's a river of air that runs from west to east aloft in the atmosphere. It runs at about the altitude planes fly, near the top of the troposphere, just kind of below the stratosphere, going up at the tropopause when the stratosphere is transitioning into the troposphere. And it's generated by the cold air at the poles, relative to the warm air at the equator. So the temperature difference is really what drives this jet stream. And you have this nice east to west, or west-east rather, motion across the northern hemisphere, and you have a similar motion in the southern hemisphere. So in particular, I'd like to take a look over here at the jet stream on the Atlantic side of the planet. And I'm particularly interested in this wind anomaly which is developed over the equator. So what we have here is very strong winds aloft, and you can see that this jet stream pattern is overall a lot of mixing is occurring between the northern and southern hemisphere jets. So you have, this lead coming off the northern hemisphere, coming out over the Atlantic basin, crossing, mixing here with the southern hemisphere jet, coming down, recovering Africa over here at, maybe Angola or Namibia, and then coming back up, from the southern hemisphere, we have this meander coming off of Brazil, large swath of mixing, and then coming back down here and merging back again with itself. So there's a lot of crosstalk between the northern hemisphere jet and the southern hemisphere jet. And what's particularly disturbing about this anomaly is that it persists for many days. So, if we kind of step forward in time here to now, you can see that the jet stream patterns are still crossing. This is the weather map for today. You can see there's a lot of crossing, a lot of looping of the jet stream going up, coming back, coming out, crossing over the Horn of Africa here. So very strange patterns. Stepping back in time, you can see that this pattern is persistent. It's lasting for, almost a week here. Stepping back even a few more days, you can see it starting to develop here on the 11th. So this kind of crossing is very concerning because it bespeaks to the overall effects of abrupt climate change. These kinds of winds are very strong winds, and you can see that this pattern even repeats itself here over the Horn of Africa. You have another branch of the jet stream coming down and interacting with the southern hemisphere jet, more mixing before it swings back up over the Indian continent. So what we're looking at here, folks, is a broken jet stream pattern. This crosstalk is very anomalous between the two hemispheres, especially on such a grand scale. So in order to get a better understanding of this, we can swing up here into the Arctic and have a look at some of the wind patterns up in the Arctic. And we can see here that, there's a lot of very strange wavy behavior of the jet stream up here in the Arctic. And this is due to the fact that, the Arctic is warming due to abrupt climate change. The warmer air in the Arctic is causing divergences in these wind patterns. And this is expected as, all the pressure gradients and such change with warmer air. So you have a lot of turbulence here. The jet stream is coming up here, off the coast of Greenland and then looping back on itself, cutting way down, over here near the Greece even, and then cutting way back up over here over the Black Sea, over the Caspian Sea, and then merging back down with that mixing that's going on here over the East Africa. So, a lot of very odd behavior. I mean, even considering we have very strong winds up here at the North Pole. This is 79 kilometer an hour winds, jet stream winds actually traversing the North Pole. So this is, very aberrant behavior, folks. And what you're going to see with this is a lot of changes in weather patterns. In order to get a deeper understanding, and we can look at some of the ocean temperatures, I think that's, very useful, because up here in the Arctic, we have a lot of very warm water. If we look here, we have, Iceland, this is 6.9 degrees Celsius. This is the absolute temperature, so the temperature at the surface. We have the Faroe Islands here, 9.2 degrees C. Coming up here off the coast of Norway, 7 degrees C, 6.4 degrees C up here north of the Arctic Circle. Up here by Svalbard, we have some very warm pools, 12 degrees C, anomalously warm pool. Coming over here, we have the Russian islands, and, this water here is supposed to be frozen, folks, and, you can see it's 0.3 degrees C, 1 degree C. I mean, sea surface or seawater freezes at, minus 1.8 degrees C due to the salinity. So, I mean, this is about 2 degrees warmer than average, warmer than it should be. And we can quantify how much warmer it is than normal by looking at the sea surface temperature anomaly map, and we can get a sense of how much away from average we are. You can see we have a lot of warm pools kind of collecting here in the Arctic, making it hard for sea ice to form. We have 7.6 degrees C warmer than normal here off the coast of Svalbard. We have 8.8 degrees C, another very warm pool, and then 3.6 degrees here, Russian islands again. Coming down here, we have another warm pool, 2.4 degrees C warmer than average here over Iceland. And, this is a lot of heat being transported into the Arctic, and this is what's driving our very strange jet stream patterns. If we look at the Atlantic basin overall, you can see it's pretty much all quite a bit warmer than average. If you look at the Gulf Stream here off the east coast of North America, 5.3 degrees C, waters off of Nova Scotia, 2.7 degrees C warmer than normal. There's a cold pool concentrated here near the center of the Atlantic basin, Greenland here. And this may be, meltwater coming off from the season or the previous season that was dumped off of Greenland during the summer melt season. This cool pool is kind of being absorbed by the overall warming. So in the context of the jet stream, folks, I mean, what this is going to do is this is going to bring, very aberrant weather patterns. It's going to be a lot warmer than usual, or maybe a lot colder than usual. There's going to be cold periods followed by warm periods followed by cold periods. Everything's just going to start to become a lot more unpredictable with the weather systems. So that's the overall effect of this, folks, is, we are dealing with a totally different climate system. And, this is not a climate system that we really understand, and it's changing very rapidly. So with that, folks, I think I'm going to wrap up this special climate outtake. I hope you found it useful, and if you did, please comment, like, and subscribe. Thanks for listening.